In this video tutorial, I will explain to you some simple ways to follow when you are naming and writing the IUPAC name of an alkene or alkyne. Now, first, you need to memorize the prefixes of the main chain carbon. So if you have 1 carbon, it's a meth, 2 carbon, it's an eth, 3 carbon, prop, 4 carbons, chain bute, 5 pent, and here you can remember the pentagon being having 5 sides, hex for 6 carbon, and 6 has an X in it, so this reminds me with hex. Now, hept, oct, non, and dec, remember this: September, October, November, and December. Like this, you can still remember the order of the name of carbons. Now, I have a rule that I always tell my students: if you are naming a branch, you are going to follow this rule, but you will end the name with the 2 letters YL. However, if you are naming the parent main chain, I'm talking here about alkenes and alkynes, you should always start by a number. You then mention the name of the carbons you are naming. Like, for example, if I have a chain of 6 carbons, I would say hex, and then I will end it with ene. But I have to put a number before hexene to locate the double bond. So for an ene, there's a double bond, and ine, there's a triple bond. Let's begin with the first example. So first, count how many carbons you have. 1, 2, 3, 4, 5, and 6. So here I have 6 carbons. 6 carbons means I have hex. Now this one is called hex. Now, when I want to name it, it's an hexene because I see a double bond over here. However, there are some priorities we need to consider when naming an alkene. And in naming the alkene, the priority goes in numbering from the side that it's closer to the double bond. So if you number from here, 1, 2, 3, 4, 5, your double bond is on the second. It says 2 hexene. Whereas if you number from this side, 1, 2, 3, 4, 5, 6, your double bond is on the 4 hexene. And that is wrong because I have a chance to number to start counting from the left, giving the double bond the lowest possible number. So the final answer for this question is 2 hexene. Now let's take another example. So here's another name. First, you select the longest carbon chain, including the double bond. I always tell my students, start writing the name from the end to the start. So here I have 1, 2, 3, 4, and I have 5 carbons. 5 carbons is a pent. So I'm gonna write pent. Now what is this? This is an alkene. So I will write pentene. And here comes the numbering. Am I going to number it from the right side or from the left side? We need to check to see the priority. And the priority is to give the double bond the lowest possible number. So if I count from the right, the double bond is taking number 2. But if I count from the left, 1, 2, 3, I am giving 3 the double bond, and that's not correct. So I prefer to start numbering from the right side. So this is a 2 pentene. Now, in this chain, I have 2 branches. Remember, I told you the branch will end with YL, and there's always a number for every single branch to locate it. So this branch has one carbon, and one carbon is meth. And since it is a branch, you are going to add to it YL. So that's a methyl. However, this methyl is on the third. So I say 3-methyl. And this methyl next to it, also this is a methyl, but this one is on the fourth. Now, in writing the IUPAC system, the IUPAC name of an alkene or alkyne, we do not write the same name of the branches repeatedly. We can use the prefixes di, tri, and tetra. Di if I have the same branch repeated twice. Tri if I have the same branch repeated 3 times. And tetra if it's repeated 4 times. So here I have the methyl repeated twice. So I'm going to say dimethyl. And it is coming on the third and on the fourth. So I put the numbers together, 3 and 4. And even if it's the same number, I'm going to write it twice. So the final answer for this compound is 3,4-dimethyl 2-pentene. Now let's take another example. Now, in this one, again, we select the longest chain. 1, 2, 3, 4, 5, and 6. I have 6 carbons in the given example. So 6 carbons means a hex. Now, in this compound, I have a double bond. So I'm going to say hexene. And then directly I'm going to give it a number. Now, let's check. Is this correct to number it from the right side or from the left side? If I count from the right side, 1, 2, 3, the double bond comes on the third. But if I count from the left side, 1, 2, and 3, as well, the double bond is coming from is also on the third carbon. So here we move to the next priority. And the next priority, other than giving the double bond the lowest possible number, you look at your branches. Coming from this side will give the double bond the lowest possible number, but as well, it will give the branches the lowest possible number. So I am going to count from the left side. So 1, 2, 3, 4, 5, and 6. So this one is going to be hexene. Where's the double bond? It's on the third. Now, in this one, I have 3 branches. Every single branch has 1 carbon. So that's a methyl, that's another methyl, and that's a third methyl. As I mentioned, if you have 3 branches of the same name, you are going to write trimethyl. You're not going to write methyl, methyl, methyl 3 times. However, since you have 3 branches, I need to see 3 numbers at the beginning of the name because every branch begins by a number. So, my branches, 2 of them on the second carbon, so I'm going to write 2 twice, and 1 of them is on the third carbon. So the final name is 2,2,3-trimethyl 3-hexene. Now, one more example. So we begin by counting the longest chain. 1, 2, 3, 4, 5, 6, and 7. We have 7 carbons, and 7 carbon means a hept. So we have a hept. Now, this is a double bond, so I'm going to say heptene. Now, where is this heptene? I need to put a number and locate this double bond. If I count from this side, 1, 2, 3, the double bond comes on the third. But if I count from this side, 1, 2, 3, and 4, I will give the double bond a higher number, and that is not correct. So I'm gonna stick to the right side. 1, 2, 3, 4, 5, 6, and 7. So that's a 3-heptene. Now this 3-heptene has a branch with 1 carbon. So that's a methyl. As a branch, I will give it YL and 5. Now, I'm gonna make some slight changes in this question. And what if you have over here CH2, CH3? What would be the name of this compound? So the numbering will still be the same, 3-heptene, but the branch now changed. 2 carbons means F. So instead of saying methyl, you are going to write ethyl. And this ethyl is still on the 5th carbon. Now let's take some examples of drawing. If I have the name and I need to draw, as an advice, always start from the last part of the name. So first of all, I see a hex. So we have a chain of 6 carbons. 1, 2, 3, 4, 5, and 6. Now, by looking at the suffix, I see -ine, hexyne, means that I have triple bond. Where exactly this triple bond? It's on the 1st carbon. So I write it on the 1st carbon. And again, I have another branch. How did I know that this is a branch? It's ending with YL. So I have a branch where exactly? On the 4th carbon. So this is the 1st, this is the 2nd, this is the 3rd, this is the 4th. A 4th, now ethyl, I take you back to the list. If I have an F, it means 2 carbons. So I'm gonna draw 2 carbons consecutively. And you are done. Now all you have to do is complete your chain with the required number of carbons. Note that every carbon can make up to 4 bonds. They are either 4 single bonds, or double and 2 single, or triple and 1 single. So this carbon over here is having 1, and the rest will be all hydrogens. This carbon over here is having 1, 2 bonds, now 3 and 4. Now this one, 1, 2, 3, and 4. This one over here, 1, 2, 3, and 4. This one, 1, 2, 3, 4. This one here, 1, 2, 3, and 4. This one, no more bonds, 1, 2, 3, 4, and this carbon, only 1. Let's take two more examples. I'm gonna do them in a faster way. Hept means 7 carbons. Ine means I have a triple bond. Where exactly? On the 2nd carbon. And I have 1 branch on the 5th carbon, and I only have 1 carbon branch. So 1, 2, 3, 4, 5, 6, and 7. On the 2nd carbon, I have a triple bond, and on the 5th carbon, 1, 2, 3, 4, 5, I have a branch. The remaining will be filled with hydrogens. Just like that. H, H. So that's the final drawing structural formula of this 5-methyl 2-heptine. Okay, last example in our video tutorial, we look at oct, means I have 8 carbons. It's an ene, means I'm going to draw a chain of 8 carbons with a double bond. Where exactly? On the 3rd carbon. Now, this chain has 2 branches, 1 methyl, 1 carbon on the 4th, and another branch of 2 carbons on the 5th. So let's begin by drawing 8 carbons. 1, 2, 3, 4, 5, 6, 7, and 8. As I mentioned, on the 3rd, I have a double bond. 1, 2, 3. Here's the double bond. On the 4th, I have 1 carbon chain. So 1, 2, 3, 4, and here's the first branch. And on the 5th, I have 2 carbons because it's called ethyl. So here's the 5th. I'm gonna draw it from below. 1 and 2, and that's it. Now let's place the hydrogens. This carbon, 1, 2, 3, 1 hydrogen. I can give it 1 more hydrogen. This carbon, no more hydrogens. This one, only 1 hydrogen remains here and here. And that's all.